Okay, a couple of hints. You should recall that the defining characteristic of a power function could be taken as the fact that it's a y equals x to the p function, or could be taken as the fact that when x doubles, y changes by a constant factor. So, your test we don't have numbers, and we're not going to impose numbers on these graphs. Your test is going to be based on the second criterion, which is equivalent to the first. Does y change by a constant factor when x doubles? Question mark. Now, is that the case? Let's take one of the graphs. Let's just take this one. Okay? So we can have, well, any of the graphs. We take this one, and I'm not going to work out the entire solution, but I'm going to have a series of x values that double. Now, to get a series of x values that double, I'll start by picking an x value and take half of that, and take half of that, take half of that, take half of that, and even take half of that. Although these last couple of points don't seem to correspond to actual graph points. Okay? So, at least we have a point here, and a point here, and a point here on the graph that will correspond to 3 of these x values. So does, and possibly a point here. You can, of course, scale the graph the way you want to. Now, of course, you're looking at this graph on a computer screen. Now, there's a very good chance that in corresponding to the link to this document, you have some graphs that sort of correspond to these graphs, and you could use those. Or you could just copy these graphs down and do your best to match the shape of each graph, the characteristic of each graph, and then line it off on a piece of paper. There are other things you could do on a computer screen. Take a piece of paper, a strip of paper to correspond to the x-axis, and mark it off and hold it there, and so forth on the computer screen. If you're using a large screen, that can work. If you got a little tiny screen and you're looking at this thing on some mobile device that gives you a screen too small to really work with, well, work with something else. Or, as I say, make your copy, but look very carefully at the graph and make sure you mimic the shape of the curve and its position relative to the x and the y-axis. Okay, well, that's the only hint I'm going to give you. You can mark these off, and you'll have a graph point here, and you'll have a graph point here, and you'll have a graph point here, and then do as the test dictates. I'm not going to do that part, at least on this video. Okay, now with these graphs, what do we get? Okay, well, let's just take this graph and let's sketch a curve that seems to match the trend line. This curve seems to follow a trend something like this. Now, when I do the trend line, I'm not attempting to go through any of the data points. I'm just trying to fit the trend of the data. And that takes a little practice to do that. You can draw some of these and draw your own trend lines. Okay, and I'm not sure how well I'm going to do with this, just because of the angle I'm looking at the board, at which I'm looking at the board. But hopefully I'll do well enough that you can get the idea. So I think the trend is something like this. Okay, now I didn't do a real good job of that. I've got 1, 2, 3, 4 points above the curve, 1 point below the curve, and a couple of points, or at least the chalk line goes through the data point. Now, a perfect trend line with real-world data where the real world data actually represents irrational numbers. There's overwhelming chance that any number you observe is irrational, since the cardinality of the irrationals is infinitely greater than the cardinality of the rationals. And you might or might not be aware of that, and if you aren't, you can ignore that. But there's actually zero chance that with actual scattered data, you're actually going to go through any data point. So you never try to go through any data point. You follow the trend. Now, I should have lifted this curve up a little bit. I could do better. And actually, I'm going to try to do a little better. The shape of the curve looks good to me. I should have just made it a little bit higher. So I'm going to just kind of do this. I'm going to make it about this much higher. And now, maybe it's closer, maybe it's too high. Okay, you can play around with that. Now, my question is the same for this curve. Okay, I can pick x values corresponding to the range or the domain of the data, and I can rule it off. And then I can test whether, let's see, I'm going to use a different color for the corresponding points on the curve. Okay, now the other thing is I want to use the curve. I'm done with the data points. I've fit a trend line to the data points, forget them, ignore them. So now I'll have a point here, and 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 I'll come up here, and I'll have a point here, and I'll come up here, and I'll have a point up here. Okay, well, we can test according to the test. We can look at these points according to the test for a power function and make a decision. So that's the sort of thing you would do with each graph.